Hello everybody, a very warm welcome to all the viewers of wisdomjobs.com. In this video, I am going to discuss an objective question which might be expected in one of the competitive examinations like CHSL, CGL or NTPC RRB or other any competitive examinations. So please do subscribe to our channel wisdomjobs.com because we are going to do many objective questions which are probable in the competitive examinations which are forthcoming in the next month and the summer season. So please express your queries or doubts at the bottom of the video in the comment box provided, so that whenever we find time we get back to you and answer your queries. The question for this video is: the number of electrons in a particular orbit is given by which theory? So he has given you the options: Heisenberg's uncertainty principle, de Broglie's particle duality, Pauli's exclusion principle and none. And let me read out in Hindi also. किसी विशेष कक्षा में इलेक्ट्रॉनों की संख्या किसके द्वारा दी गई है? ए हाइजेनबर्ग अनिश्चित सिद्धांत, डी ब्रोगली का कण द्वैत, पाउली की बहिष्करण सिद्धांत और इनमें से कोई नहीं. So now let us look at the given options. The first option is Heisenberg's uncertainty principle. Now the name itself indicates it is uncertainty. So the position of an exact electron cannot be determined. So determined with 100% probability. That's what is the postulate. That's what is the postulate of Heisenberg's uncertainty principle. So obviously it is not having anything. It is nothing to do with the number of electrons in an orbital. So Heisenberg's uncertainty principle is not a correct option. Next, coming to the second option, de Broglie's particle duality. So it can act as any particle. It can be a part of matter, and it can act as it can exhibit particle nature and a photon nature. That's what is the duality proposed by de Broglie's particle duality. Okay, so obviously option B is also not a correct example. Now coming to Pauli's exclusion principle. Pauli's exclusion principle says that no two electrons have the same set of quantum numbers. So talk about the Pauli's exclusion principle in a particular orbit. It definitely deals with the number of electrons present, and so C is our correct option. Okay, so the option C is the perfect match for the given question. So the correct option for this question is option C. The question for this video is: magnetic moment quantum number represents A. The options are the energy of a level, the orbital angular momentum, the possible orientations of an electron orbit, and none of the above. If I read it in Hindi, चुंबकीय कक्षा क्वांटम संख्या किसके दर्शाता है? तो ऑप्शन ए इस एक स्तर की ऊर्जा, कक्षीय कोणीय कक्षा, इलेक्ट्रॉन कक्षा का संभव अभिविन्यास और इसमें से कोई नहीं. Now let me go for the first option, the energy of a level. So the energy of a level is described by the principal quantum number of a particular orbit is described by principal quantum number. Next, coming to the second option, the orbital angular moment. So the angular moment of an orbital is described by the azimuthal quantum number. It is described by azimuthal quantum number. Next, the possible orientations of electron orbit. Yeah, so this is done by expressed by the magnetic quantum number, which is represented as, so the representation for principal quantum number is N. Here it is L, here it is M. So of course our possible orientations of the electron orbit are described, or they are represented by the the magnetic quantum number. Okay, so C is the correct option for us. Next, let us move to the next question. The question for this video is nuclear force charge independent? The options are yes, no, maybe and none. Now if you observe the nuclear force, basically the nuclear force is due to either alpha particles or beta particles. Okay, and then of course bombardment. Now if you observe, the nucleus does not contain any sort of charges. I mean, it is neutral always, so it does not have any free charges. So if I am hitting a nucleus, it will be it will not have any effect on the protons or the outside electrons. So what is happening, I think I can say that the nuclear force is basically due to the removal of either alpha particles or beta particles from a particular atom, from a heavy radioactive element atom. So here there is no loss of charges, or here there is no gain of charges. So for that reason we don't have any force generated by the nucleus. So obviously the force that is generated is only due to radioactive radiations, but not due to the charges. So obviously the nuclear force is charge independent. So for that statement, what would be the answer? Yes. So the nuclear force is definitely charge independent. So obviously the correct option is A. So the correct option is A. Yes, and we cannot say maybe because there is no option of no, and similarly the option of no is anyhow incorrect. So obviously A is the correct option for this particular question. The force responsible for radioactivity is, the options are A nuclear force, B gravitation, C electromagnetic force, and D weak force. Now let me read it in Hindi also. रेडियो धार्मिकता के लिए जिम्मेदारी बल वो क्या होता है? परमाणु बल, या आकर्षक शक्ति, या विद्युत चुंबकीय बल, या वीक बल. So let us analyze the given four options. Now coming to nuclear force, nuclear force is generally generated due to either emanation of alpha particles or beta particles. So the radioactivity is spontaneous emission. Okay, so it is due to the spontaneous emission. So obviously the nuclear force is not the correct option. Next, coming to gravitation. Basically the particles that are generated or emanated by a radioactive element are weightless. Okay, so due to that, what is happening, the gravitational force should have a mass at least so many milligrams or grams. But if you observe the particles that are emanated by a radioactive element, their mass might be something like femtograms or sometimes picograms. So that small mass is not sufficient for generating the gravitational force. So obviously gravitational force is also wrong answer. Coming to electromagnetic force, basically they are not charged particles. So if they are having some charge in them, remnant charge in them, then there is a chance of them to become electromagnetic force. But since there is no creation of electric field and magnetic field by a nuclear emanations, so obviously I can say that electromagnetic force is not the correct option. And obviously weak force. So these radiations, the radioactive activity radiations are generated, or they are produced by weak forces. So obviously D is the correct option. So weak force, D is the correct option for this particular question. Hope you enjoyed this video. Please do subscribe to our channel wisdomjobs.com and share and like these videos to your friends, so that they also will be benefited by these videos and they also can get good scores in the competitive examinations. So if you have got any queries, please express them in the comment box provided, and as and when we find time, we are going to answer your queries. Thank you for watching. Have a nice time.